Good afternoon, students. In the last class, we are discussing about the friction, right? So that is static friction. When one object which is placed on the another object, that means when two objects which are in contact, when a force is applied on the object, so there exists a force, so that force we call as a friction, and that friction is always in tangent with the surface in contact. So in between two surfaces ಅಲ್ಲಿ ಇರುತ್ತೆ. So ನಾವು ಯಾವಾಗಲೂ ಅದನ್ನ indicate ಮಾಡೋದು small f, right? So where f is capital F is the applied force. So this friction, so now ಎಷ್ಟು force apply ಮಾಡ್ತಾ ಇದೀವಿ, so same force which is exerted by the friction, that means contact between the two surfaces, right? So up to a certain limit, so now ಎಷ್ಟು force apply ಮಾಡ್ತಿದೀವೋ so ಅಷ್ಟು ನಮಗೆ friction ಬರುತ್ತೆ. So that type of friction we call as static friction. So that object should be keep in rest. So rest ಅಲ್ಲಿ ಎಲ್ಲಿವರೆಗೂ ಅದನ್ನ object place ಆಗಿರುತ್ತೋ ಅಂತ friction ಅನ್ನು ನಾವೇನ್ ಕರೀತಿದೀವಿ, static friction, right? So in the yesterday class also we discussed about the limiting friction, that is FL, that is equals to Fs maximum. So the maximum value of the static friction we call that one as the limiting friction. And in the exam if they ask for write the loss of friction, means we have to write the loss of limiting friction. That means limiting friction loss is it is independent of area of contact and it is directly proportional to the normal force acting on the object, that is between the surfaces, right? So now where F is the force which is applied, if we plot the frictional force to that of the applied force, right? Where Fs is the frictional force and F is the applied force. So now graph na plot ಮಾಡ್ಕೊಂಡ್ರೆ, so what it states, now force increase ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ friction force ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. For example, I am applying 10 Newton force that is on the object, then friction will be also 10 Newton. 15 Newton applied force ಮಾಡಿದ್ರೆ friction ಕೂಡ 15 ಇರುತ್ತೆ. So 20 Newton apply ಮಾಡಿದ್ರೆ friction force ಕೂಡ 20 Newton ಇರುತ್ತೆ. So that is up to a certain limit. That means we getting the curve that is a straight line, right? So if we plot the graph for the frictional force, that is static frictional force to the applied force, we get a curve. So that curve we call as the straight line that is passing through the origin, right? So next condition is when applied force applied force is capital F. So if the applied force which is less than the limiting friction, right? So if S maximum we call that one as the limiting friction. So now applied ಮಾಡ್ತಿರೋ limiting friction value ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ then that object is at rest, right? So now apply ಮಾಡ್ತಿರೋ force limiting friction value ಗಿಂತ ಕಮ್ಮಿ ಇತ್ತು ಅಂದ್ರೆ object ಏನಿರುತ್ತೆ, rest ಅಲ್ಲಿ ಇರುತ್ತೆ. So same way if the applied force F which is greater than the limiting friction value, so now apply ಮಾಡ್ತಿರೋ force limiting friction value ಗಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ then the object will starts to move, right? So ಇದನ್ನ ನಾವು last class ಅಲ್ಲಿ discuss ಮಾಡಿದ್ವಿ, right? So next type of friction, that is kinetic friction. So kinetic friction means when one object moves on the another object, then the force will exist. So that type of force we call as kinetic friction, right? So kinetic friction is a force which come into play or which come into exist when one object will move on the another object, right? So ಯಾವುದಾದ್ರೂ one object another object or another surface ಮೇಲೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so ಅಂತ friction ನಾ ಏನಂತ ಕರಿತೀವಿ ನಾವು, kinetic friction. So what is kinetic friction? When one object moves on the another object, so there exists a opposing force, there exists a opposing force in between the contact of two objects, right? In between the two objects, then that force is called as kinetic friction or dynamic friction. So static means ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಬರುತ್ತೆ. ಸೊ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಕೂಡ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಫ್ರಿಕ್ಷನ್ ಬರುತ್ತೆ. ಸೊ ಅಂತ ಫ್ರಿಕ್ಷನ್ ನಾವೇನಂತ ಕರಿತೀವಿ, ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ the object is moving. While the object is moving on another surface, then that type of friction we call as kinetic friction. So ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಯಾವುದ್ರ ಮೇಲೆ, on the another surface of the object, so there exists an opposing force or resisting force, so that force we call as a kinetic friction, right? So or dynamic friction. So kinetic friction is denoted by Fk, where F is a friction. So small f with the suffix k, it indicates what? The kinetic friction. So SI unit of kinetic friction is Newton, because friction is also a force, right? So here we have two types, right? So one is sliding friction. So kinetic friction na another name alli ನಾವು sliding friction ಅಂತನೂ ಕರೀತೀವಿ, right? So the second is rolling friction. So sliding friction means when one object slides over on the another object, so that type of friction we call as sliding friction. So ಯಾವುದಾದರೂ ಒಂದು object another object ಮೇಲೆ slide ಆಗ್ತಾ ಇದೆ, that means move, slide, both are same. Either it may be on a horizontal surface or it may be on a inclined surface, right? So horizontal surface ಮೇಲೆ ಬೇಕಾದರೂ slide ಆಗಬಹುದು ಅಥವಾ inclined surface ಮೇಲೆ ಬೇಕಾದರೂ slide ಆಗಬಹುದು. So there exists a force, so that force we call as sliding friction or kinetic friction. So that is also indicated by Fk, right? So if the object is sliding downwards, then the friction will act opposite to that Fk, right? So sliding friction and kinetic friction, we consider both are same. So hence we indicate the sliding friction with the alphabet Fk, k suffix, that is kinetic friction, right? So next, rolling friction. Rolling friction is roll of one object on the another object. So ಯಾವುದಾದರೂ ಒಂದು object roll ಆಗ್ತಾ ಇದೆ on the another surface, then that type of friction we call as rolling friction. So there exists a friction, so that we call as rolling friction, and it is denoted by F suffix R. R indicates what? Rolling friction. So ಯಾವುದಾದರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ರೋಲ್ ಆಗ್ತಿದೆ, either it may be ಸರ್ಕಲ್ ಇರಬಹುದು, ಇದೇ ರೋಲ್ ಆಗ್ತಾ ಇದ್ರೂ ಕೂಡ ಇಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋ ಫ್ರಿಕ್ಷನ್, ದಟ್ ಈಸ್ ಆಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್. ಸರ್ಕ್ಯುಲರ್ ಆಬ್ಜೆಕ್ಟ್ ಸ್ಲೈಡ್ ಆಗಲ್ಲ, ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೋಲ್ ಆಗುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ a friction, so that friction we call as rolling friction, right? So the coefficient or the rolling friction is always less than that of the sliding friction, right? So rolling friction is less than the sliding friction or kinetic friction. So ಯಾವುದಾದರೂ here in these two cases ಎರಡು objects ಏನಾಗ್ತಿದೆ ನಮಗೆ ಮೂವ್ನೇ ಆಗ್ತಾ ಇರೋದು, one is sliding and another one is rolling. So here the force which exists, opposing force which exists in the rolling objects, so that value is less than that of the objects which are sliding on the surface of the other object, right? So ಇದನ್ನ ನಾವು ನೆನಪಿಟ್ಕೋಬೇಕು. So rolling friction is always less than that of the sliding friction or kinetic friction, right? So again, from the kinetic friction, loss of kinetic friction or friction, right? So consider one object which having mass m and it is moving with some velocity, right? So there exists a friction. So ಯಾವಾಗಲೂ ಮೂವಿಂಗ್ ಡೈರೆಕ್ಷನ್ ಗೆ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಆಗಿ ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. So that friction we call as kinetic friction. So ಅದು in between two layer surfaces in between ಅಲ್ಲಿ ನಾವು represent ಮಾಡ್ಕೊಂಡು friction. So ನಾವು exam ಅಲ್ಲಿ represent ಮಾಡ್ಬೇಕಾದ್ರೆ in the lower surface, so not above. ಈ ತರ indicate ಮಾಡ್ಕೊಳಂಗಿಲ್ಲ ಅದನ್ನ friction, because friction is a contact force. So contact force means two surface contact ಅಲ್ಲಿ ನಮಗೆ force exert ಆಗ್ತಿರೋದ್ರಿಂದ so ನಾವು surface ಅಲ್ಲಿ ಅದನ್ನ represent ಮಾಡ್ಕೊಂತೀವಿ, right? So the object is moving, right? So here also the loss of kinetic friction or loss of static friction or loss of limiting friction both same. So here also it is independent of area of contact. So it is similar to that of the limiting friction, right? So first point is it is independent of the area of contact, and the second point is it is independent of velocity of object. So object ನಮಗೆ fast slow ಆಗೋದು ಮೂವ್ ಆಗಬಹುದು, right? So moving object ಅಲ್ಲಿ ನಮಗೆ friction ಬರ್ತಿದೆ ಅಂದ್ರೆ ಆ friction ಅನ್ನು ನಾವು kinetic friction ಅಂತ ಕರೀತೀವಿ. So the kinetic friction is independent of the velocity of the object. Either the object may be fast moving or slow moving, the kinetic friction is always remains same. And the third point is the kinetic friction Fk is directly proportional to the normal of the object, right? That is the normal force of the object, right? So F is directly proportional to N. So again, if we remove the proportionality constant, Fk, that is equals to mu k into N, right? Where mu k is a constant, that is proportionality constant, and we define that one as coefficient of kinetic friction. So mu k is defined as coefficient of kinetic friction, and it is unitless quantity, right? So mu k another namge it has no units, right? So we define mu k, that is equals to Fk divided by N, where N is also a force, friction, kinetic friction is also a force. So force k unit Newton divided by Newton, so get cancels. So mu k is equals to Fk by N. Fs mu s kuda asta, it is also a unitless quantity, right? Again, this normal force is equals to the weight of the object, that is N is equals to mg. So we can write mu k is equals to mg divided by Fk divided by mg. So ಇವೆಲ್ಲದನ್ನು ಕೂಡ ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಸೊ ಬಿಫೋರ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಹಿಯರ್, ಸೊ ಗೊತ್ತಿರಬೇಕು ಇದನ್ನ ಯಾವ ತರ ಬರ್ಕೊಳ್ತಾ ಇದೀವಿ ಅಂತ. ಆಲ್ವೇಸ್ n is equals to mg. So these two are equal and opposite, hence these two are get cancels. So ನಾವು ಇಲ್ಲಿ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವೋ this force is equals to Fk, right? So here mu k is the coefficient of the kinetic friction and mu s is the coefficient of the static friction, and here we are getting one mu r, where mu r is the coefficient of the rolling friction, right? So from the experiment we can state that coefficient of static friction mu s is greater than coefficient of kinetic friction is greater than coefficient of rolling friction, right? So as the coefficient of static friction is more than the coefficient of kinetic friction, so that means static friction is greater than that of the kinetic friction, and also it is greater than that of the rolling friction, or friction in rolling objects is less than that of the friction in the sliding objects, and also the friction in rolling sliding objects is less than the static friction, right? So sliding objects ನಾವು ಎಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಐಸ್ಬರ್ಗ್ಸ್ ಮೇಲೆ ನಾವು ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗ್ತೀವಿ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಸ್ಲೈಡ್ ಆಗ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಸೊ ಅಲ್ಲಿ ಏನಿರಲ್ಲ ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ವೆರಿ ಲೆಸ್ ಇನ್ ಸ್ಲೈಡಿಂಗ್, ರೈಟ್? And also in rolling. So this for this reason, so ಇಲ್ಲಿ ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಆನ್ ರೋಲಿಂಗ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ wheels, so So now transportation ಗೆ wheels na use ಮಾಡ್ತಿರೋದು ಇದೇ purpose ಗೆ, because friction is very less in rolling objects. So ಇವೆಲ್ಲ key points ತರ ಎಲ್ಲದೂ ಕೂಡ ನಮಗೆ ನೆನಪಲ್ಲೇ ಇರಬೇಕು, because in competitive exam ಅಲ್ಲಿ reasons ಕೇಳಬಹುದು ಅಥವಾ greater than, which one is greater than and which one is lesser than. So ಏನ್ ಕೇಳಿದ್ರು ಕೂಡ ನಾವು ಬರೆಯೋ ತರ ಇರಬೇಕು, right? So these are the types of friction. So one is static friction and another one is kinetic friction. So in between we getting one value, that friction is nothing but the maximum value of the kinetic friction, static friction, right? So again here, if we plot the graph for overall friction to that of the applied force, that is F. So ಈ graph ತುಂಬಾ important, right? So ಇಲ್ಲಿ ನಮಗೆ friction ಅಂದ್ರೆ ಎರಡು ಬರುತ್ತೆ, one is static friction and another one is kinetic friction. In between static friction and kinetic friction we are getting one friction, that one is the limiting friction. So now apply ಮಾಡೋ force limiting friction ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ static friction existence ಅಲ್ಲಿ ಇರುತ್ತೆ, ನಾವು apply ಮಾಡೋ force limiting friction ಗಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ kinetic friction existence ಆಗುತ್ತೆ, right? So mainly two types we having: static friction, kinetic friction. In between one value we are getting, that one is the limiting friction. This value is always lies in between the static friction and kinetic friction, right? So first, this F means overall friction, right? So ನಮಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಕೇಳ್ತಾರೆ, that means competitive exam, applied force is always capital F. So F is a friction. ಈ friction ಅಲ್ಲಿ ನಮಗೆ kinetic friction ಇರುತ್ತೆ, static friction ಇರುತ್ತೆ. So ಎರಡು ಸೆಪರೇಟ್ ಅಲ್ಲ, ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ initially we having the static friction. After it crosses the limiting friction, the object starts to move. So while moving also, the object will have some friction. So that friction we call as kinetic friction, right? So initial relation in the applied force is directly proportional to the static friction. So now ಎಷ್ಟು force apply ಮಾಡ್ತಾ ಹೋಗ್ತೀವೋ ಅಷ್ಟು ನಮಗೆ static friction ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ, right? So that one we get it the curve in a straight line, linear curve, and starts with the origin. So origin ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Force apply ಮಾಡ್ತಿಲ್ಲ ಅಂದ್ರೆ friction ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. So that's why it starts from origin, right? So ನಾವು ಯಾವುದೇ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಫ್ರಿಕ್ಷನ್ ಇರೋದಿಲ್ಲ. So ನಾವು 1 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ನಮಗೆ 1 ನ್ಯೂಟನ್ ಫ್ರಿಕ್ಷನ್ ಸಿಗ್ತಿದೆ, right? So this is the maximum limit. So ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ, FL, or we call this one as FS maximum, right? So ಎಲ್ಲಿವರೆಗೂ ಲೀನಿಯರ್ ಇರುತ್ತೆ, up to a certain limit ವರೆಗೂ ಲೀನಿಯರ್ ಇರುತ್ತೆ. So next ಏನಾಗುತ್ತೆ, the curve will get it like this, and again constant, right? So this one is the limiting friction, FL, right? So the region up to here, the applied force, it comes under the limiting friction. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ಏನು ಬರುತ್ತೆ, so ಇದಿಷ್ಟು ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ನಮಗೆ static friction. So above this we are getting that value. So ಇದು ಏನಿರುತ್ತೆ ನಮಗೆ FK, kinetic friction, right? So kinetic friction is always less than that of the static friction. So ಇದು ವ್ಯಾಲ್ಯೂ ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಇದು ಎಷ್ಟೇ ಸ್ಪೀಡ್ ಅಲ್ಲೂ, for example we are getting some 5 newton as kinetic friction. So the object, if we move in 10 meter per second, the kinetic friction is 5 newton. If the object is moving 100 meter per second, then also the object is 5 newton itself, right? So that means it is independent of the velocity of the object, hence the kinetic friction value remains constant, right? ಸೊ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಲೀನಿಯರ್ಲಿ ವೇರಿ ಆಗುತ್ತೆ. ಫೋರ್ಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಎಲ್ಲಿವರೆಗೂ ಅಪ್ ಟು ದಿಸ್ ಲಿಮಿಟ್. ಆಮೇಲೆ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಗೇನ್ ಸಮ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಲೈನ್ ಸ್ವಲ್ಪ ಕೆಳಗಿದೆ, ನಥಿಂಗ್ ಬಟ್ ಈ ವ್ಯಾಲ್ಯೂ ಇದು ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ದಟ್ ಮೀನ್ಸ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ದ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಅದನ್ನೇ ನಾವು ಇಲ್ಲಿ ಬರ್ದಿರೋದು, ಎಲ್ಲಿ F R is less than Fk less than Fs. So Fk value ಯಾವುದು ಕಮ್ಮಿ ಇರಬೇಕು, ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಡಾಟೆಡ್ ಲೈನ್ಸ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿರೋದು ಮೋರ್ ವ್ಯಾಲ್ಯೂ. ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ದ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್, ಓನ್ಲಿ ಸ್ಮಾಲ್ ವೇರಿಯೇಷನ್. ಸೊ ಒಂದೊಂದು ಹೇಳ್ಬಿಟ್ಟು ನೀವು ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲೆಲ್ಲೋ ಈ ತರ ಡ್ರಾ ಮಾಡಿದ್ರೆ ದಟ್ ಗೋಸ್ ರಾಂಗ್, ರೈಟ್? ಸೊ ಓನ್ಲಿ ಸ್ಮಾಲ್ ವೇರಿಯೇಷನ್. So graph property na represent ಮಾಡುತ್ತೆ. So perfect type of graphs, right? So that one is the important graphs. And two types of the friction, sliding and rolling friction. Theory ಅಲ್ಲಿ ನಮಗೆ ಕಡಿಮೆ ಇದೆ. So important in the friction is the first one is loss of friction. So 2 marks ಗೆ ತುಂಬಾ ಸಲ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವೆಶ್ಚನ್ ಕೂಡ ಇದೆ. ಲಾಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಅಂದ್ರೆ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಆಗಿಲ್ಲ ಕೈನೆಟಿಕ್ ಅಥವಾ ಲಿಮಿಟಿಂಗ್ ಆರ್ ಸ್ಟಾಟಿಕ್ ಅಂದ್ರೆ ಎಲ್ಲದಕ್ಕೂ ಓವರ್ ಆಲ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ದ ಟೂ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್. ಒನ್ ಇಸ್ ಇಟ್ ಇಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ದಿ ಏರಿಯಾ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ನಾರ್ಮಲ್. ದಟ್ ಇಸ್ ನಾರ್ಮಲ್ ಮೀನ್ಸ್ ನಾರ್ಮಲ್ ಫೋರ್ಸ್. ಕಾಂಪಿಟೇಟಿವ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ತುಂಬಾ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರುತ್ತೆ ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ. ಸೊ ನೆಕ್ಸ್ಟ್, ಆಂಗಲ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್. Angle of friction, right? So again, considering one object which is placing on the another object, right? So here we are applying some force. So ಈ ಕಡೆಯಿಂದ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ pull ಮಾಡ್ತಾ ಇದೀವಿ, ಈ ಕಡೆಯಿಂದ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಪುಷ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಡಿಫರೆನ್ಸ್ ಗೊತ್ತಿದೆ ತಾನೆ? ಸೊ ಇದು ಆಬ್ಜೆಕ್ಟ್ ನ ಎಳೆಯೋದು, ದಟ್ ಮೀನ್ಸ್ pulling the object. ಸೊ ಈ ಕಡೆಯಿಂದ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಪುಷಿಂಗ್ ದ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ಎರಡು ಕೂಡ ನಮಗೆ ಫೋರ್ಸ್. ಈ ಕಡೆಯಿಂದ ಏನಾದರೂ ಆಕ್ಟ್ ಮಾಡಬಹುದು ಅಥವಾ ಈ ಕಡೆಯಿಂದ ಏನಾದರೂ ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ನಾವು ಯಾವ ಕಡೆಯಿಂದ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಮಾಡಿದ್ರು ಈ ಕಡೆ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ದ ಫ್ರಿಕ್ಷನ್ ವಿಲ್ ಬಿ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗಲೂ ಅಪೋಸಿಟ್ ಟು ದಟ್ ಆಫ್ ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಫ್ರಿಕ್ಷನ್ ವಿ ಟೇಕನ್ ಆಸ್ Fk, kinetic friction. That means the object is moving. So ಇಲ್ಲಿ Fk represent ಆಗಿದೆ ಅಂದ್ರೆ the object is moving, right? So one more force is the normal. So this is the applied force F. Here F is also a force, normal is also a force. So normal is a contact force which is always perpendicular to the contact of the two surfaces. Now ಇಲ್ಲಿ represent ಮಾಡ್ಕೊಳ್ಳಬಹುದು, surface ಗೆ perpendicular represent ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, right? These two forces is acting on an object, right? So now force kuda vector, normal kuda vector. The resultant force between the two forces. So ನಮಗೆ ಒಂದು resultant ಇದೆ ಅಂತ ನಾವು ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಇನ್ನೊಂದು ಈ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. So the resultant again from the parallelogram law of vector addition, if we complete this one we get a square or rectangle, right? So ನಾವು ತಗೊಳ್ಳೋ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇದು ಯಾವುದನ್ನು ತಗೊಂಡ್ರು parallelogram law of vector addition ತಗೊಂಡ್ರೆ ನಮಗೆ resultant gives the diagonal. So diagonal gives the resultant of the two forces, right? So this we taken as R or R dash. R ಅಂದ್ರೆ ಮತ್ತೆ ನಾರ್ಮಲ್ ಆಗುತ್ತೆ. So ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ in place of n they write R, that means reaction force or normal force. ಎರಡು ಕೂಡ ಡಿನೋಟ್ ಮಾಡ್ಕೋಬಹುದು. ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ R ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ n ಯೂಸ್ ಮಾಡ್ತಾರೆ. So don't confuse with these two. So both are same. So that's why here I am taken the resultant is R dash, right? Now so angle of friction is defined as theta here, right? So angle of friction is the angle between the resultant of the two forces, that is one is applied force and to the normal force, and angle between the normal force and to the resultant of the two forces, right? So how we define the angle of friction means it is the angle between the normal force, right? So this is the normal angle between the normal force and that of the resultant between two forces. One is applied force and to the normal. So ಇವೆರಡು ಫೋರ್ಸ್ ಗೆ ರಿಸಲ್ಟೆಂಟ್ ಇರೋದನ್ನೇ ನಾವು ರಿಸಲ್ಟೆಂಟ್ ಬರ್ಕೊಂಡಿದೀವಿ. ಈ ರಿಸಲ್ಟೆಂಟ್ ಜೊತೆಗೆ ನಾರ್ಮಲ್ ಫೋರ್ಸ್. ಸೊ ಈ ಆಂಗಲ್ ನ ನಾವೇನಂತ ಕರಿತೀವಿ? Angle of friction, right? So it is defined as angle between the normal force and the resultant force of applied force and normal force, right? So angle of friction is always lies between the normal force and to that of the resultant force. So this resultant force we are getting from the applied force and to that of the normal force. So ಇವೆರಡಕ್ಕೂ resultant ತಗೊಂಡಿರೋದೇ ನಮಗೆ resultant, right? So ಈ resultant normal ಜೊತೆಗೆ ಎಷ್ಟು angle form ಆಗಿರುತ್ತೋ ಆ angle ಅನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? Angle of friction, right? So this is the definition. So now we need to write in the mathematical form, right? So from this triangle, right? So from this triangle, if you consider this one as ON R dash, ON from the triangle ON R dash, tan theta, right? So tan theta is equals to opposite side by adjacent side. So opposite side indicates what? The force which we are applying, that is F, right? And the adjacent side is what? The force which we are getting, so that is N, right? Tan theta is equals to opposite side by adjacent side. So this applied force is equals to the kinetic friction. So now ಎಷ್ಟು force apply ಮಾಡ್ತಿದೀವೋ ಅಷ್ಟು ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ? Kinetic friction. So the relation is, or we can write this one as kinetic friction Fk is equals to mu k into N, right? So this F we can write that as Fk because the applied force is equals to the kinetic friction, right? So tan theta is equals to Fk divided by N, right? So here Fk and N is there, so we can replace this one. Fk by N is equals to mu k, right? So here we can write tan theta is equals to, in place of Fk by N we can write that one as mu k, right? So this is when, so in moving consider model static ke consider now initial state Fs, because applied force is equals to the static force Fs. So Fs is equals to mu s k mu s Fs. So this becomes Fs. Mu s, right? So that is tan theta is equals to mu s, where mu s is what? The coefficient of static friction. So we can also change this to mu k. Mu k is equals to tan theta, right? So we can replace mu s by mu k while when it is in moving. So ಇದನ್ನ rest ಅಂತ consider ಮಾಡಿರೋದ್ರಿಂದ tan theta is equals to mu s, right? So the coefficient of static friction we can also define in terms of angle of friction, that is coefficient of static friction is equals to tangent of angle of friction. So this is also one more important relation. Tan theta is equals to mu s. So now ಕೆಲವು derivation derive ಮಾಡಬೇಕಾದ್ರೆ direct ಆಗಿ in place of tan theta we need to substitute mu s or mu k. So depend on situation. Object moving ಅಲ್ಲಿ ಇದ್ರೆ mu k substitute ಮಾಡ್ತೀವಿ, rest ಅಲ್ಲಿ ಇದ್ರೆ mu s substitute ಮಾಡ್ಕೊಂತೀವಿ. So ಇದು ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. Tan theta is equals to mu s. So the coefficient of static friction we can also define in terms of angle of friction, that is mu s is equals to tan theta, or tan theta is equals to mu s, right? So this is about the angle of friction, right? So next one more is there, that is angle of repose. So ಇದು ನಿಮಗೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬೋರ್ಡ್ ಅಲ್ಲಿ ಇಲ್ಲ ಬಟ್ necessary ಇದೆ, right? So what is angle of repose? So as we are discussing the kinetic friction, that is the sliding friction, right? So angle of repose, we take that angle as alpha. So angle of repose, we denote that one by the alpha, right? So in the theta ತಗೊಂಡಿದ್ದೀವಿ, so ಬೇರೆ we taken here alpha, right? So what is angle of repose means? It is the angle made by the inclined plane to the horizontal surface. So horizontal surface ಅಲ್ಲಿ ಇಲ್ಲಿ object ಇಟ್ಟಾಗ ನಮಗೆ ಬರ್ತಿರೋ angle ಏನಿದೆ ನಮಗೆ angle of friction. So ಇದು horizontal surface. So same surface if we incline, so now horizontal surface na solpa incline madidre some angle is formed in between the horizontal surface and to that of the inclined surface. So we call this one as horizontal surface. So this we call inclined surface, right? So same object, so pen ಇಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ pen ಮೇಲೆ ಒಂದು object ಇದೆ ಅಂದ್ರೆ what we are doing means we are inclining the plane. That means the surface na ನಾವು ಏನು ಮಾಡ್ತಾ ಇದೀವಿ incline ಮಾಡ್ತಾ ಇದೀವಿ. So incline ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ automatically object ಏನಾಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಸ್ಲೈಡ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದೀರಾ? So ಯಾವುದಾದ್ರೂ ಒಂದು object ನ incline ಮಾಡಿದ್ರೆ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಸ್ಲೈಡ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So that is the object starts to move in this direction. So that means it has some acceleration. So now all your over bada, right? So that angle we call as angle of repose, right? So it is the angle formed by the inclined surface to the horizontal surface such that that angle made the object starts to slide. So now certain angle ಅಲ್ಲಿ ಇಟ್ರೆ ಕೆಲವೊಂದ್ಸಲ ಸ್ಲೈಡ್ ಆಗೋದಿಲ್ಲ. So angle incline ಮಾಡ್ತಾ ಹೋದಾಗೆಲ್ಲ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, object slide ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So ಅಂತ angle ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, angle of repose, right? So here the weight of the object is always acting downwards. So ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, right? So ನಾನು ಆಲ್ರೆಡಿ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ, ಸರ್ಫೇಸ್ ಈ ಕಡೆ ಇದೆ ಅಂದ್ರೆ ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗಲ್ಲ, it is always acting downwards. So that is mg, right? So next here it is n. So object ಈ ಕಡೆ ಸ್ಲೈಡ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ there is a friction. So that friction is the static friction or kinetic friction. Ready to start means limiting friction. So ಇಲ್ಲಿ ನಾವು limiting friction ತಗೋಬಹುದು ಅಥವಾ kinetic friction, right? So now this component, this angle is also equals to alpha, right? So now resolving the component along horizontal and along vertical. So this component we getting mg sin theta. So here we are getting mg cos theta, right? So ಈ mg ಅನ್ನೋದನ್ನ ನಾವು ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ along vertical and along horizontal, right? So again this is the force and this is also the force. So equating the forces, we getting Fk is equals to mg sin theta. So Fk ಈ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, mg sin theta ಈ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, then those two forces are equal. Next, normal force is equals to mg cos theta, right? So that is n is equals to mg cos theta, right? So here also we will take this one as static friction or maximum static friction, that is limiting friction, right? So statical examples now calling these two as equation 1 and equation 2. So divide equation 1 by equation 2. So we get Fs by n, that is equals to mg get cancelled, we get sin, sorry, this is alpha, right? Sin alpha cos alpha, right? So sin alpha by cos alpha, so we call that one as tan alpha, again from the trigonometry. So sin alpha by cos alpha is tan alpha, right? So again Fs by n, So fs by n ಏನು ಬರ್ಕೊಂಡಿದ್ದೀವಿ ನಾವು mu s, right? So from this we can write mu s, that is equals to tan alpha. So coefficient of static friction we can also write in terms of angle of repose, right? So mu s is equals to tan alpha. So angle of repose andre it is the angle which is made by the inclined plane so that the object starts to slide. So moving slide agbeku, just rest alliro object ಏನು ಆಗಬೇಕು, it starts to move, that means maximum limiting friction. So initially statical irutte, that means the object is in no motion, right? So that is mu s is equals to tan alpha. So this is also one more important relation. Mu s is equals to tan alpha, where alpha is the angle of repose, right? And the next is relation between angle of friction and angle of repose. So the relation between angle of friction and angle of repose. So illa ide namage relation mu s is equals to tan theta, again mu s is equals to tan alpha. So from these two equations, so I will write here mu s is equals to tan theta. So this is from the angle of friction, theta is the angle of friction, where theta is the angle of friction, right? So the same case mu s is equals to tan alpha, where alpha is the angle of repose. So e angle ಬೇರೆ ಇದೆ ಮತ್ತೆ e angle ಎರಡು ಬೇರೆ ಬೇರೆ ಇದೆ, right? So now in the LHS we having the same term, that is coefficient of static friction. So LHS same ಇತ್ತು ಅಂದ್ರೆ automatically RHS ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ same ಇರುತ್ತೆ. So that's why tan theta is equals to tan alpha. So again here also tan of an angle is equals to tan of an angle. So here tan of 30 degree ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೂಡ ಏನಿರಬೇಕು ನಮಗೆ tan of 30 degree. Tan ಇದೆ ಅಂದ್ರೆ automatically ಇಲ್ಲಿ ಏನಿರಬೇಕು 30 degree ಇರುತ್ತೆ. So that means we can write theta is equals to alpha. That means angle of friction is equals to angle of repose. Angle of friction, that is equals to angle of repose, that is theta is equals to alpha, right? So ನಮಗೆ ಈ ಎರಡು ಕೂಡ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಬಟ್ ನೆಕ್ಸ್ಟ್ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋ ಟಾಪಿಕ್ ಮೇಲೆ ಇದು ತುಂಬಾ ಇಂಪ್ಯಾಕ್ಟ್ ಆಗಿರೋದ್ರಿಂದ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಇವೆರಡು ಆಂಗಲ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಸಾಲ್ವಿಂಗ್ ಮಾಡಬೇಕಾದ್ರೆ, ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಎರಡು ತುಂಬಾ ಫ್ಯಾಕ್ಟರ್ ಆಗುತ್ತೆ. ಸೊ ನಮಗೆ ಆಂಗಲ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ, ದಟ್ ಇಸ್ ಆಂಗಲ್ ಆಫ್ ರಿಪೋಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, ಸೊ ದೇರ್ ಇಸ್ ಅನ್ ಆಂಗಲ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಅದರಿಂದ ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬಹುದು, coefficient of static friction. So for example alpha is 30, then we can find the coefficient of static friction. So tan 30 is root 3 or 1 by root 3, right? So 1 by root 3 we get the value of static friction, that is coefficient of static friction, right? Next, so pull ಮಾಡಿದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ, ಪುಷ್ ಮಾಡಿದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ? ಡೈಲಿ ಲೈಫ್ ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ತೀರ ತಾನೆ, ಪುಷ್ ಮಾಡೋದನ್ನ ಏನಂತೀವಿ, ದಬ್ಬೋದು. ಸೊ ದಬ್ಬಿದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಬೇಗ ಅಂದ್ರೆ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ, ಇಳಿದ್ರೆ ಬೇಗ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ? ಪುಲ್ ಮಾಡಿದ್ರೆ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ, ಪುಷ್ ಮಾಡಿದ್ರೆ ಈಸಿಯಾಗಿ ಮೂವ್ ಆಗುತ್ತಾ? ಪುಷ್. ಸೊ ಫಿಸಿಕ್ಸ್ ಓದ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಯಾವುದೇ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಳ್ಬೇಕು ಅಂತ ಏನಿರ್ಬೇಕು, ಅದಕ್ಕೊಂದು ಮ್ಯಾಥಮೆಟಿಕಲ್ ರಿಲೇಷನ್ ಇರಬೇಕು. ಸೊ ಮ್ಯಾಥಮೆಟಿಕಲ್ ರಿಲೇಷನ್ ನೋಡ್ಕೊಂಡೆ ನಾವು ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ. ಯಾವ್ದು ಈಸಿ, ಪುಷ್ ಆರ್ ಪುಲ್? ಸೊ ಒಂದು ಬೀರು ಇರುತ್ತೆ, ಸೊ ಪುಷ್ ಮಾಡಿದ್ರೆ ಈಸಿಯಾಗಿ ಹೋಗುತ್ತಾ, ಪುಲ್ ಮಾಡಿದ್ರೆ ಈಸಿಯಾಗಿ ಹೋಗುತ್ತಾ? ಬೀರು ಏನಿದೆ, ಒಂದು ಸ್ಟೋನ್ ತಗೊಳ್ಳಿ ಅಥವಾ ಯಾವುದೋ ಒಂದು ಸಣ್ಣ ಆಬ್ಜೆಕ್ಟ್, ಎರಡು ಕೇಸ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ. right? So in the first case, consider an object which having mass m, right? So now I am pulling this object. So pulling means I am applying some force. So pull ಮಾಡೋದು ಅಂದ್ರೆ ಎಳೆಯೋದು ತಾನೆ. So I am applying some force. So this is F, right? So ಈ ಕಡೆ direction ಅಲ್ಲಿ pull ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ object will move in this direction. So there exists a friction. So that we can take kinetic friction. So object move start ಆಗ್ತಿದೆ ಅಂದ್ರೆ kinetic friction, right? So again here we have one more force, that is normal. Again we having the force which is always acts downwards, right? So this force is counterbalanced by the normal force. So ಈ ಎರಡು force ಏನಾಗಬಹುದು ನಮಗೆ cancel ಆಗುತ್ತೆ, right? So ಇಲ್ಲಿ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋದು ಯಾವುದು? In the case, so this one is pull, right? So now this force is resolving into two components. So already the vector start ಮಾಡಿದಾಗ ಹೇಳಿದೆ. So the concept is very important, right? So this makes an angle some theta with the horizontal, right? So theta with the horizontal is ಅಂದ್ರೆ we are resolving the component. One is along the horizontal and along the vertical, right? So now the horizontal component becomes F cos theta. No, take theta with the vertical, that is angle of friction. We will discuss the angle of friction, right? So here we take angle theta. So force which makes angle theta with the vertical, then this component force we getting, that is F sin, F cos theta, right? So opposite to that of the angle, we getting the force here, that is F sin theta, right? So now if you observe here, so ಈ force ನ ಎರಡು ಕಾಂಪೊನೆಂಟ್ ಆಗಿ ರಿಸಾಲ್ವ್ ಮಾಡಿದೀವಿ. One force is acting vertical, that is F cos theta, and another is the force which is acting along the horizontal, where theta is the angle of friction, right? So now initial stage ಅಲ್ಲಿ ಏನಿದೆ, this force will balance the weight, that is downward force is equals to the upward force. So downward ಎಷ್ಟು force act ಆಗ್ತಾ ಇರುತ್ತೆ ಅದಕ್ಕೆ upward ಕೂಡ ಅಷ್ಟೇ force ಏನಾಗ್ತಿರ್ಬೇಕು ನಮಗೆ act ಆಗ್ತಿರ್ಬೇಕು, right? So that means n plus F cos theta, that is equals to mg, right? So upward force, ಎರಡು force act ಆಗ್ತಿದೆ. One is component of the applied force and another one is the normal force, right? So in the same way, the force is acting in this direction, so friction is acting in the opposite direction. So that means Fk is equals to F sin theta, right? So from this, what we can rearrange? Again, n is equals to mg, right? Okay, we can write this one as mu k n is equals to F sin theta. Right. N plus F cos theta is equals to mg, and F k is equals to F sin theta. Mu k n is equals to normal. So along horizontal we can take angle theta, right? So here we take f cos theta. So here we getting f sin theta, right? So n plus f sin theta, that is equals to mg. So upward force, two forces are acting. One, the component which is resolving along the horizontal and which is resolving along the vertical. So n plus f sin theta, that is equals to mg, right? So from this we can write n is equals to mg. We are shifting this term to the RHS, that is minus f sin theta, right? So n is equals to mg minus f sin theta, right? So again from this equation, f cos theta, that is equals to fk, right? So this is the force which is along the horizontal, and that force is always opposite to that of the force, that is the friction, fk, right? So we know the applied force f, that is friction force fk, that is equals to mu k into n, right? So this is from the definition of the kinetic friction. So kinetic friction is equals to coefficient of static friction into n, right? So here we having the value of n, so we can find fk, the force of kinetic friction fk, that is equals to mu k into the value of n is mg minus f sin theta, right? So calling this one as equation 1, right? So this is when we are pulling this object, right? So now considering in the second case, so that is pushing, right? So forcefully ikkada pull ಮಾಡ್ತಾ ಇದೀವಿ. So same directionally we are applying the force, that means push ಮಾಡ್ತಾ ಇದೀವಿ, right? So this force is what, f. Again here the force acting is mg, and here it is the normal. So ಈ force ನ parallel ಆಗಿ ನಾವು ಬರ್ಕೋಬಹುದಾ? So in this direction ಇದೆ ಅಂದ್ರೆ, so the force will be in this direction. So this is the applied force. So ನಾವು ಕಾಂಪೋನೆಂಟ್ ರಿಸಾಲ್ವ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಯಾವಾಗಲೂ ಕೂಡ ಟೇಲ್ ಎಂಡ್ ಅಲ್ಲೇ ನಾವು ಕಾಂಪೌಂಡ್ ನ ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೋಬಹುದು. ಸೊ ಹೆಡ್ ಎಂಡ್ ಅಲ್ಲಿ ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಬರಲ್ಲ, ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡ್ರೆ ರಾಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಟೇಲ್ ಎಂಡ್ ಅಲ್ಲಿ ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ವಿ. ಸೊ ಐದರ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಹಿಯರ್ ಆರ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಹಿಯರ್, ರೈಟ್? ಸೊ ಹಿಯರ್ ವಿ ಟೇಕನ್ this as angle theta, then here it is becomes angle theta, that is because of the opposite angle. So illi angle theta idu andre illi kuda angle theta, right? So if it is theta means here also theta. Now resolving this component, so here we getting f cos theta, here we getting f sin theta. So if force na resolve ಮಾಡಿದ್ರೆ horizontal force f cos theta and f sin theta. So from this we can relate n, that is equals to upward force, that is equals to vertically downward force. So vertically downward force ಏನಿದೆ ನಮಗೆ f sin theta plus mg. So ಈ ಎರಡು ಫೋರ್ಸ್ ಏನಾಗ್ತಿದೆ, ಆಕ್ಟ್ ಆಗ್ತಿದೆ. ದಟ್ ಮೀನ್ಸ್ ಡೌನ್ವರ್ಡ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಎರಡನ್ನೂ ನಾವು ಆಡ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇಲ್ಲಿ vertically upward ಇರೋದ್ರಿಂದ n plus f sin theta, that is equals to mg, right? So that means we take a minus here, right? So again from the kinetic friction formula, fk is equals to mu k into n, right? So mu k as is, the formula becomes f sin theta plus mg, right? So ಇದರಿಂದ ನಾವು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು, this one is the frictional force. So frictional force, so force ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ friction force will be in this direction. So ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ friction ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಇಲ್ಲಿ ಈ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ friction ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಇಲ್ಲಿ towards the positive axis ಅಲ್ಲಿ friction ಆಕ್ಟ್ ಆಗ್ತಿದೆ. So there is a difference. Difference means value will be less. So ಇಲ್ಲಿ add ಆಗ್ತಿದೆ, so value will be more. That means kinetic friction in case of push is more than the kinetic friction in case of pull. So we can write that one as fk in case of push is greater than fk in case of pull. So friction ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, so ನಾವು ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗಿರೋ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So pull ಅಲ್ಲಿ friction ಕಮ್ಮಿ ಇದೆ, so that means the object will easily move, right? So that's why it is easy to pull an object than push. So ಈ statement ಗೆ mathematical relation ಈ ಎರಡು, right? So ನೀವು ಬೇಕಿದ್ರೆ solve ಮಾಡಬಹುದು. If the mass of an object is some 10 kg, right? So ಈ object mass ಎಷ್ಟಿರುತ್ತೆ 10 kg ಇರುತ್ತೆ. So some angle theta is we consider some 30 degree. So 30 degree ನಾವು force ನ apply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ some kinetic friction. So this is constant. If we taken this value as some 0.5 Newton, right? So ಎಲ್ಲ values ನಾವು ಕೊಟ್ಟಾಗ first we find the pull value, right? So force of friction, that is 0.5 into 10 into acceleration due to gravity is always constant, so that is 10. So F ಗೆ ಕೂಡ ನಾವು value ಕೊಡೋಣ some 5 Newton. So 5 Newton force apply ಮಾಡ್ತಾರೆ, right? So minus 5 into sin 30, right? So 0.5 we can write 1 by 2, 100 minus 5 into 1 by 2. So sin 30 is 1 by 2. We get some 2.5, right? So 100 minus 2.5 is what is that? 97.5, right? Divided by 2. So Fk is equals to 2 4s are 8, 2 8s are 16, 2 7 are 14. So Fk is some 48.75 Newton. So general example ತಗೊಂಡಿರೋದ್ರಿಂದ friction force ಅಷ್ಟು act ಆಗ್ತಿದೆ when in the case of push or pulling. So same if you apply here, sorry, in pulling. So if you apply here, so Fk is equals to 0.5 into F, that is 5 into sin 31 by 2 plus m into g, 10 into 10, right? So that is 1 by 2, 2.5 plus 100, right? So 102.5 divided by 2, so 2 5s are 10, 2 1s are 2, 2 2s are 4, so 51.25 Newton. So now compare these two values. So push ಅಲ್ಲಿ ನಮಗೆ ಎಷ್ಟು ಬರ್ತಿದೆ 51 ಬರ್ತಿದೆ, pull ಅಲ್ಲಿ 48 ಬರ್ತಿದೆ. ಸೊ ಯಾವ್ದ್ರಲ್ಲಿ ಕಡಿಮೆ ಇದೆ? pull ಅಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ನಮಗೆ ಕಡಿಮೆ ಇದೆ. ಸೊ push ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ.